Sorry about this. I've been trying to get this Streamlabs OBS. I just updated, right? Finally, I just typed a nice title a minute ago, right? And a really long description, well, about 4 or 5 lines, right? And I clicked on go live. What happens? I get a twirly thing on the screen. It doesn't do sod all. It just crashes on me. Well, it doesn't crash on me. I just ended up quitting because it wouldn't do anything. So this time I created a title, really short title, and in the description I just put duh, right? Because I'm not going to waste my time filling in a description if it's not going to work. And now it's working. Ah! All right, I'll just edit this. I'll edit the description later. So if you're watching this live and the oh god, it's put my flipping aspect ratio. Yeah, the aspect ratio is completely messed up now. Oh, it's flipped it around now. Oh, at least that's something. Okay, right. So I've been taking a break. So I called it test coils number 4 because when I originally was doing a test, when I first started out, I was using these coils, 2 of which had previously wound, and we had quite good results with those because they were kind of mismatched. I'm starting to think that mismatched coils seem to stop it, go on there. So and then in the second test I wound these smaller coils with what was it, 22 SWG, I think it was, yeah, 22 SWG wire. Pretty sure it was 22. Yeah, it is. Anyway, that was the second set of coils. Then I have the third set of coils, which I've taken off now, which are these, and these actually I'll get my calipers just a minute. Sorry about the mess. Right, so the second set of coils let me go back to the first set. Right, the first set of coils were 14.73 millimeters. That was the first set I did. Then I did the second set, and the width of these coils, was 10.63 millimeters wide with thicker wire. The third set was these coils at 14.9 millimeters with 25 SWG wire, and now with an extra 4 millimeters on top of that, so just add 4 millimeters, I've got the new coils wound, right? So, and it's a damn sight better. Now, if you remember, when my output voltage on the output stages, sorry about the capacitor just sitting on top there, it's just handy. So I've got the 4 new driver coils on here now, and the stupid capacitors are already charged up, right? Because we're at we're actually at 12.9, almost 13 volts, and I'm still pushing 30 milliamps in, which is bloody good, considering I'm actually, normally we're about 50 milliamps or lower on the output, but look at that, we're still at, well, pretty much 100 milliamps, so that's really good. I'm about to discharge them, so 98.5 milliamps, and my input current is the same. We're at 90 milliamps on the high side, pulsed at 35.5, actually it says 5.2, but it's not, because if I set this, we are at 35.5, that's what it's set at. Don't know why it was jumping up to 35.2, I don't know. Right, we're at 90 milliamps on the high side, pulsed, with the pulse width. The pulse is going in to drive the MOSFET, so on the blue trace. That's half of it, because I'm not measuring the positive cycle I'm only measuring the negative cycle on here. I could put the scope probe. I've only got 2-channel scopes, so the yellow trace is the output. So we're actually doing better. Look at that, 36.6 volts peak to peak, 14.8 volt RMS. On the low side, we're still at 16 volts before it's boosted up, so we're at 16 volts. I haven't changed this actually. Oh, that's current actually. We're at 16 volts, now we're on volts. We're still at 16 volts, I haven't changed that. And the input current with we're actually no load at the moment, we're about 325 milliamps, but that drops when we short this out. So if I actually get if I get a jumper lead or a resistor, actually, let me just get I can't find that resistor, it's somewhere around here, somewhere. Where is that resistor? There we go. Actually, I misread this resistor previously. It's about 1 ohm actually, because I think it's 0.8 something ohms. I don't know, I've forgotten what it is now. It doesn't really matter anyway. It's a very low value, but when I put this across any of the output coils, you watch when I put it across the scope, the trace will disappear. Look, right, it's disappeared. Right, we've got about 2 volts peak to peak across there now. The input current has dropped right down. I don't know if you can see the meter over there. It's dropped down to 230 on the low side. I can't hold this on. Let me just try and get this wedged in there somehow. Oh, it's falling out. It's better if I stick a lead on it actually. Let me find some leads. I've run out of freaking leads again. I need to. Every time I buy leads, I end up using them all. Right, what I'm going to do. Oh, what's going on here? Oh, I've got that on there. Sorry. Bit of a mishap. I'm having mishaps at the moment. Right, so if I clip this onto the output stage is here. I'll clip that on. These slimy, horrible clip leads are horrible. Right. I hope my audio is working. Right, I'm going to stick my resistor, clip this onto this resistor, which will short that out. Right, well, now look, the input current has dropped to 60 milliamps on the high side. This resistor across the output. On the low side, we have dropped right down to 225 milliamps on the low side. So the input current goes down with the load. That's with this resistor across. Is it getting warm? Don't know. I can't feel any heat on it actually. Let's put it on a different. Let's put that resistor on another output. There's another output down here. I can do this with one hand. Look at the sparks coming off it. Oops, slimy leads. These leads are horrible. Ah, get on. Right, that's on. We're back down to 60 milliamps. I won't go up there or across there to show you that, it'll be the same. So look at that, low current when we load it down, and we've still got, look at that, 55 milliamps coming out the other coils. Even with these coils shorted, we've still got 55 milliamps coming out. Right, and that is genuine, because now it's gone back up, taking it off, it's gone back up to 95. So, yeah, it's a damn sight better, because that's what I would expect normally, 55 milliamps, around about that, when the output has got to about 12 volts, 13 volts. Actually, I'm going to discharge that now. So what I'm going to do, I'm just going to discharge this supercapacitor. There we go, it's discharging now. It's going to put that power into the battery. So we're seeing no current going in because it's not taking current in at the moment. And that power is now being sent to my battery, which is down. So we're now putting 1.95 amps from the supercapacitors into the battery right now. Once that supercapacitor is discharged, we will see how much current we are getting on the output. At the moment it's still at 95 milliamps. That's brilliant. Now just remember, think back a bit to the previous videos I was doing. Normally during the supercapacitors being discharged, we would see that current drop off right down to about 30 milliamps, right? But we've still got 95 milliamps, and that's going into these supercapacitors that are down here, right? Ones that are down at the bottom, you can just about see them, yeah. And also those supercapacitors with the yellow LEDs on, so they're currently charging those up right now. So right, and as they do, you'll see that the voltage on the AC side, where it says 14.7 volts, that's measuring AC, that will start to climb slightly as the supercapacitors at this side are being charged, while the ones across the room are being discharged. And as soon as that hits the bottom, the relay will click off, and we'll see a surge in current on this side. So that's what we're waiting. The relay should click any minute, and we'll start to see the output current go up as the voltage that it's going into starts to fall. We will start to see, and I've actually had some pretty good results with it. It goes up to about 150 milliamps on the output. I think it's more than that actually, I'm not sure. We'll have to check. It will be more when it's starting from bottom end. I mean, if we're going into something like 4 volts, it will be a lot higher, but 200 milliamps. But yeah, it's encouraging. So alright, just click there, look, because now we're seeing this voltage on the AC side start to drop, and as that drops, we're seeing the current on the output go up. And as that happens, our input current drops. So that's where we are at the moment. I'm just going to mount this. I'm going to try and put this stand over here so we can actually move that meter out of the way. I'm just going to try and put my phone on here so you can watch that for a bit. Oh, it's too low. Damn it. Hang on. Oh, it's too low. Hang on. No, I'll have to hold it, I suppose. My meter's a bit... Oops, let me take this thing off. So we're seeing it go up, which is really good. I'm just going to put this... Hang on a minute. We should be able to see it from over here anyway. I've got light reflecting right now. Right, so you can see it going up as the... Oh, sorry, my battery charge has just finished on there. So the AC voltage is slowly dropping as the RMS is being pulled down by the increased load, because this meter is measuring the AC output, which is on these two clips here from this one of the coils. So I'm only measuring one of the coils. Right, so now we're 140 milliamps on the output, near enough, 139.6. It'll be 140 milliamps in any second. There we go. So anyway, I rest my elbow on my knee because it's hard reaching out. So it's still going up. And that's into that current is, well, at some point this will stop dropping and it will start to climb again, because what happens is once the supercapacitors that are down here reach equilibrium with the supercapacitors that are up there on the thingamajig, once they reach equilibrium where they're about equal, we start to see the voltage on the AC going back up again, and we also reach the peak current on the output, which is currently that, which is going into 5.67 volts up there right now. It's hard to see an eye. We're at about 5.72 volts. It's climbing quite quickly. So let's see. Is this going to equalize and start to go back up again? I think it's about to turn any second and start to climb again. If it goes to 9.88 the minute, then it's climbing again. No, it's still dropping a bit. As long as it's dropping, we'll see an increase in current on there. I think it's going to start. There we go. It's going back up again now. So it's reached equilibrium. So that'll be the peak current that we're going to get at the moment. 142.7. It's going up. Look, still look. 142.9. Well, it's about equalised now. That's going into this voltage up here, which is at 6.14 volts now. So we're seeing 170 milliamps going into the supercapacitors that are actually at the back there. You can't really see them very well, but there's 6 of them. The board's mounted on the outside. But anyway, yeah. So what I'm saying is that the new coils around are actually a lot better. You can tell that from the fact that I'm still putting in about the same input current at the same voltage, and we're getting a lot more out, which is great news. So when I get this new core material, when we improve the coupling on the secondary stages, we should get even more output. Well, we will do, I should think. However, there's another thing I was thinking about the other day about a new design on this, which is to actually have secondary coils directly above the actuator input coils, directly above between the steel cores here. So instead of having the secondaries just in the gap at the top, I was thinking about putting secondary coils directly above the actuator coil here and on the other side. That way I'll have to make this thing a lot bigger, make these stands longer to hold it all, but that way I could effectively have 8 output coils instead of 4. So I could have an output coil on this side above the actuator coil, an output coil on this side above the actuator coil, and then these 2 on this side as outputs as well. That's what I was thinking of trying, but I haven't got to that yet. That's another thing I can try to add on. So anyway, this new Streamlabs OBS does seem to be working. Mind you, I did go and try and start it on there because I was having problems with the Um, at least the new system on the OBS is good, because it seems to have picked up the title that I typed in on the phone. I'll show you what I mean. It's picked up the title that I did type, so that's a bit of good news at least. Anyway, I'm just going to pause that virtual machine because I was actually watching snooker and then I had to go and close my browser just to get this thing, to try this thing out. I was having issues trying to get it running. I don't know what was going on with it, but anyway, the new app for the OBS seems to be a bit better, but it seems to have a lot more advertising on it, which is what you expect. Whoever's reprogramming it is trying to recoup their losses, I suppose. Yeah. Anyway, so I thought you'd be interested in that. I have observed a few anomalies because the problem with the coils being exactly equal is you get some harmonics between them. I tend to get some harmonic, so I've had to use some capacitors, which are this red thing here, basically across one set of coils to slightly off tune it, and across the other coil to create a bit of a situation where there's less harmonic interference. I don't know if you can actually hear it. It's hard to hear it, but if I reduce the frequency, which I don't really want to do because I've spent ages tweaking the dead time on the microchip. I forgot the name of the chip now, actually. See if I can give you a view of the chip, because I think I've forgotten what it is now. You can't really see it. It's almost schematic somewhere. The writing seems to have faded on it. Those LEDs are a bit bright as well, they get in my eye. Yeah, it's the what was it? I'll have to pull up my diagram to find out what it is, but just a minute, let me just see if I can get it on my computer a minute. My memory's not like it used to be. It's the TL494CN chip, and it has a dead time for adjusting the pulse width of the pulses, so you've got dead time. This is the chip, TL494CN, and that's my diagram that I drew up. And we don't really use the duty cycle, but the DT is the dead time trimmer pot. And yeah, so anyway, it's important. That dead time is very important, but it's not just the frequency, it's not just frequency dependent, it's when the pulse stops. When you inject the pulse into these capacitors, you have to basically kill the pulse at a certain point to minimize input current. Otherwise, the input current just skyrockets. It goes out of control, really. I mean, it's so twitch sensitive. I've had to use a multi-turn trimmer, which is this blue thing here. I think it's 100K actually. Don't know if we can see that. Oh, it's 50K actually. We're upside down. It's 50K. The writing's nearest us. I think it's. Oops, focus is gone now. Yeah, it's a 50K trim pot. Them LEDs look really bright on the camera. What dust on that shit. Yeah, I need to clean it as well. I'm getting dust in it. So I thought you'd enjoy that. Look at that, we're still pushing out 136 milliamps, and we're at 7.54 volts voltage on the output stage. It's picking up 90 milliamps at the top. It's picking up 90 milliamps at the top end because the other circuitry is using a bit of power at the moment, so it's pulling it down. So even though we're seeing 136 down here, we don't see it all getting through at the moment because of the MPPT, which is also up there, maximum peak power transfer module, which is also running, and on that thing up there, the thing with the red LED at the bottom down there, uses a bit of juice as well. So yeah, anyway, so we lose a little bit of juice on that until it goes into an idle state. Right, so anyway, update's finished. As soon as I get these new cores, this new core material, we'll do another video on that sometime. I've got to do some SketchUp designing as well, some more modelling for the core holders and all that. Well, I might live stream that at some point as well. I don't know really, because I don't think people enjoy watching me do all the live streaming of the 3D modelling. I think I get a bit bored. At least I've not really had any comments on it. So if people don't comment on my videos, I assume that they're not interested in them, so I don't bother making them, you see. So if you want to see that kind of stuff that I'm videoing, if you want to see it, you'll have to let me know, because I'm not going to make videos for something if nobody's going to comment and nobody's going to give me a thumbs. I never ask people to give me a thumbs, but I mean, if you like watching the videos, you could at least do that, because you see, the reason for the thumbs up or the thumbs down is because it tells YouTubers if the video is worth watching, and if you don't think it's worth watching, you don't comment or you don't give it a thumbs, then other people are not as likely to see it. So that's just the way YouTube works, you know. It's a recommendation. It's basically you saying, well, this video is worth watching, and yeah, obviously if people don't do that, then people don't see it, and then other people don't bother to see it, and yeah. Anyway, I'm waffling too much. I'm going on and on, but yeah, I'm gonna go, and see you later, alligator.